Welcome back to the course. Hope you enjoyed the previous sessions about deep learning and computer vision. In this session, we are going to see in detail about natural language processing. So natural language processing is nothing but like how human understand the language. For example, we understand the language, we translate them, sometimes we generate the text and speak to somebody. So this and all kind of activity with respect to the natural language, which comes under the natural language processing. Now we will see the roadmap of the NLP, how it started, how it evolved, what are the challenges it faced while evolving, and how it's shaping the future today. As I said, deep learning only focuses on like classification kind of thing. It treats all the input as the independent entity. But to understand the text, we have to understand the relationship between each text and each sentences. To achieve that, initially the initial stage of the roadmap of NLP started from ANN. Around 1980s, ANN became popular. It can able to understand it can able to classify the text, whether the text is spam text, for example spam email, or it is a real email, or it's like original email. The ANN initially used to identify the spam emails. So it's kind of simple kind of classification. It will consider the text as the numerical inputs, and then it will do some kind of processing, and then it can able to differentiate between the spam emails and the original emails. To solve this issue, in 1990, RNN was invented, and it was the very good replacement to the ANN. RNN is recurrent neural network. It understands the previous words, and then while learning the next word, it keeps on remembering the previous words, so that it can able to understand the context, so that it is used in early level chatbots and speech recognition. But the problem is that short memory. When the sentence is long, for example, dog is chasing towards cat to get the food. If this is a sentence, at the time the neural network reaches the food, it forgets what chased behind what. So this is a context it will miss due to short memory issue. This is a very challenging issue in the RNN. To solve these challenges of RNN, LSTM is invented on 1997. LSTM is nothing but long short-term memory. It introduces the memory cell to store the information. It has the three gates. One is the input gate, forget gate, and the output gate. So whenever the input information goes to output, whatever the important features whatever the important context that will be stored in the memory cell, and whatever is not needed that will be completely forgotten, or else it will be removed. So due to this, there is no memory kind of issue, so that it can able to identify context better than the RNNs. But there are two key challenges. One is that it can work for very basic level of sentences, but when it comes to long paragraphs, it will not work. And also, like it's a very high level computation, or else high level of inferences needed. It will work very slow because it needs lot of processing, so that like we cannot use it in real time. Since LSTM is invented in 1997, it became very popular in around 2014. That time only we came able to know that like it's not used for real time scenario, because it has lot of inference issues. It cannot be used in real time. In 2014, GRU, gated recurring unit, was invented. So what invention, like comparing to the previous LSTM, in LSTM, forget gate and input gate are two separate gates. But in GRU, input gate and forget gate both are merged, and it is called as update gate. Since we are merging two things into one gate, computational efficiency was very much improved, and then like inference time is very minimal, so that it can be used in real time, so that in Siri, in like Google Alexa, in everywhere this technology was used. Even though one of the real world inference problems solved by the GRU, but it doesn't work for long level paragraphs. Still that challenge was pending. And then in 2015, by LSTM came to the place. LSTM is focused on left to right processing. It only remembers the previous words. But by LSTM, it focuses on forward pass and backward pass. It remembers the forward previous words also, and also while returning to the backward pass, it remembers the future words also. Due to the like forward and backward kind of propagation, like by LSTM is performed very well. It worked for like bigger level like paragraphs. Context also very much better comparing to the previous method, but only issue is that it works very slow. And then in natural language processing, one of the game changing happened at 2017. That is the invention of attention mechanism by Google. So previously, we were like seeing all the words, and the previous words we remember and future words we remember. These are the things was going on, but attention mechanism, that was a real game changer. That is completely changed the landscape of natural language processing. The core concept of attention mechanism is that it has three main parts. One is the query, key and value. When we take a paragraph, okay, the which word we are focusing on, that is the query, and the entire paragraph will be stored in the key. And then what is the important like words, no, it will not store all the words in the memory. The value parameter, no, there only the important relationship between the two words and the important words and import context that will be stored in the value section, so that the key, query and value all combined together in the bigger level documents, bigger level kind of data sources, it only extract the important information instead of storing all the data. Due to this core concept invention, there's a big game changing activity going to happen. Because of this, the next level, bigger level of architecture, everything came into the place. By using attention mechanism, the Google came up with a very good architecture called transformer architecture. Previously we know that everything was CNN based. Now we are going to coming in the new era of transformer based architecture. In transformer architecture, the multi-level different kind of attention aids are used. As we saw that what does attention mechanism means, like lot of attention aids combined together and different level context also it can able to generate through transformer network. We can able to get what's the grammar context, what is the topic context, what is the relationship context. So any kind of relationship between the each paragraph and each words that can be achieved with the help of the transformer architecture. So this architecture will be the base for the future all the invention in the NLP. So as I said, transformer architecture is going to be the base. In 2018, Google released the BERT model. This is the first contextual model that is used in the Google translation and chatbots and everywhere. But BERT, like it trained based on the masking the text words. If there is a sentence, there will be one word will be masked. The BERT is trained in such a way that it can able to predict what word will be very suitable, which will be come into that place. And also it is trained on comparing relationship between the two sentences, what is closely related or not. So these two things helped Google to implement lot of better Google Translator and then chatbots. So in BiLSTM also bidirectional based kind of processing as we compare to the BiLSTM, but this is not generating text as of now. It only able to identify the missing words and also able to identify the relationship between the two sentences. To generate a new text in 2018, GPT came into the place. It is invented by the OpenAI. It's a very game changer of generating of text. So this GPT model trained completely on all the internet data, and then it's not the bidirectional, it is the unidirectional. It only learns from left to right. Based on this unidirectional architecture, GPT now can able to generate the text as human we do. In 2018, GPT-1 is released. That is a fast, simple text generation to write the stories and paragraphs. In 2020, GPT-3 was released. It will help us to generate the programs, and developers can able to use help of ChatGPT, and we can get all the programs whatever we need. In 2024, GPT-4 is released. Is completely multimodal. Now it can able to understand the images also. This is the complete roadmap of NLP. For the text, we see the complete roadmap. In between, vision transformer also came into the place. As like how transformer understand the text, no, in the same way it understand the images also. It will differentiate. It will divide the image into different level of patches, and then it will act as same kind of attention mechanism. It compares one patches with the all other patches, and then it will identify the what is the important patch and relationship between the patches. Based on the information, it can able to identify the images, classify the images, and then locate the images. All things was possible with the help of the vision transformers. With the help of the GPT model, vision transformers, and then generative based concepts, stable diffusion and everything all come together. Now multimodal is the game changer of the everything. Now the GPT based text generation, vision transformer based the identification, classification, and then you can see that like GPT as the text generation, vision transformation for classification, and then stable diffusion concept for generating image and everything come together. Now multimodal is a game changer. So now everything is become the multimodal, and it's completely changing the future. Now if you want to generate a video, if you want to generate an image, if you want to generate a paragraph, if you want to generate a program, everything comes together in the single model. That's called the multimodal. All the technology come together. Now it's very helpful for the world, and this invention allows anyone to do any kind of innovation with the help of multimodals. So this is the complete roadmap of how NLP started, how it evolved, what are the challenge it faced while evolving, how it's shaping the future today with the help of multimodals. So hope you enjoyed this session. We'll see you in the next session. Thank you.